So I chose to do number 9, which was the altitude of a triangle is increasing at a rate of 2.2 centimeters per minute, while the area of the triangle is increasing at a rate of 1.5 centimeters squared per minute. At what rate is the base of the triangle changing when the altitude is 11 centimeters and the area is 87 centimeters squared? So I'm going to start off with stating the angle or the area of a triangle, which is 1/2 base times height, right? And we are given a whole set of things. So first of all, we're given the derivative of the increasing height of the triangle, which is 2.2 centimeters per minute. We are also given the derivative of which the area is increasing, which is 1.5 centimeters squared per minute. We're also given the area as 87 centimeters squared per minute when we are trying to find the rate at which the base of the triangle is changing, and then as well as the height of the triangle, which is 11 centimeters at that point. So what we're trying to find is the rate at which the base of this given triangle is changing. Right here, solving for B. So we want, obviously, the derivative of the changing base length, right? And we can we can have in this equation that x equals altitude. So we're going to start off with a quotient rule with dx dt equaling b times 2 times the derivative of a for d2 minus 2a times db over dt. And all of that will go over b squared. So all of this transforms. If we have, you can see here we have this value here. So dx dt will transfer to 2.2, as you can see. And then we're going to write out b minus 174 from the 2a, which was 87 times 2, times db dt. All of that still equals, or over b squared. All right? So now we further it down. 2.2 equals 3 times 15.81. And we found this value by solving for b here, back up here. 11, our altitude, equals 174 over b, right? Area, we switched around this area, plugged in everything here, and that would leave us with a value of 15.81 as our base. So that is where this came from. And then that would be, of course, what we had before, minus 174 dB dt, like that, all over 250.21, which is a squared of this value, b squared, 15.81. I also forgot to add that the altitude formula I used to find this is basically just the area formula of the triangle, just switched around to make it so that the height is equaling to over AB, which gave me the 11 equals 174 over B, right? Okay, so moving down here, this is basically just simplifying because we have all the numbers. So this would equal out to be 47.43 minus 174 times dB dt, which we were trying to solve for, over 250.21, which would, now we would multiply by 250.21, and over here we would get 550.472 equals 47.43 minus 174 all times, right, dB dt. Now we would subtract 47.43, which would leave us with 503.04 equals negative 174 times dB dt. We're going to put that up here because we lost the space. And then we divide negative 174 by this, 503, and then we get negative 2.89 equals dB dt. So this is the rate at which the base of the triangle is changing, and that is the problem solved. Thank you.